welcome. Let's try to solve another Leetcode problem, 665, non-decreasing array. So for the problem, normally we are going to get an increasing array. So this is something like non-decreasing array. So we will get something like this. And we are given a nums with n integers. So our task is to check if it could become non-decreasing by modifying at most one element. Yeah, so the problem is that we can modify at most one element. So for example, there's another element that is higher than this element. So for example, this is 2 and this is 1. 2 is more than 1. Yeah, and we can modify this one, of course. So we can let 2 maybe become 0. So let me just make it. So we can just modify 2 to be 0. So now 2 becomes 0. So it is still non-decreasing, it is okay. Yeah. So we define an array is non-decreasing. So this is the definition. We should understand what is a non-decreasing array. So this kind of, there's no decreasing part for the array. So that array gonna be called non-decreasing array. Yeah. Let's check the first example. We're gonna have 4. This is a 4, and this is a 2, and this is a 3. Yeah. So our idea is that if we find some number that is decreasing, yeah. So for example, 2 is less than 4, we find a point, and definitely we can change 4 or we can change 2. But the problem is that whether we're gonna change this number 4 or we're gonna change this number 2. So this is the problem. Yeah. Maybe currently we don't know which number to change greatly, but maybe we just change one number. So for example, what if we just change this number 4 maybe to be 0? So 4 to be 0, it is non-decreasing, it is okay. But for this number like 4 to 3, so this is 3 is lower. Can we just change this number 2? Yeah. You know, we can change 4 to be 0, it is okay, but can we change this number 2 to somewhere, make it non-decreasing? We cannot, because 3 is less than 4, and even if we want to increase this number 2, maybe increase to somewhere, maybe increase to 4, but this number is 3, it is decreasing, but we need to make it non-decreasing. That means it is not possible. Yeah. Yeah, so the problem is that while we are finding some numbers, let me just use the first example. Yeah, so while we have this kind of 4, 2, and 3, it's like this. So for the first number, for example, it is 4, and then we find the second number, which is less than this number 4. Now, what are we gonna do? So we're going to use the greedy way to solve it. So while we find a number which is less than the previous number, so what are we going to change? Will we change this number 2 to be a 4, or will we change this number 4 to be somewhere maybe 2? Yeah. So the greedy idea is that we always want to change this number 4 to be a 2. Why? Yeah, because we don't know how large going to be the next number. So for the next number, it may be 3. Or it may be 2 or 5, we don't know it yet. Yeah, but definitely the next number is going to be more than and equal to 2. Yeah, otherwise if it is less than 2, so it's going to be false. Yeah, so the problem is that the next number is going to be bigger. So we're going to change the previous number. The previous number we just make it smaller. Maybe we just want it to be 2. Yeah, if we make it even smaller, maybe 0 or something else, it will influence other numbers. But what if other numbers may be 1, but we cannot make it to be 0? So we're gonna make it to 2. We're gonna make this number 4 to 2. Yeah. So in this way, for the next number, whether it is 2 or 3 or 4, it is okay. It always meets the conditions. That means we cannot change this number 2. If we change this number 2 to 4, it didn't work. Yeah, so this is the condition. So while we are checking the numbers, if there is a decreasing and this is just the first number and this is the second number, so this means I for the index I equal to 1. So while I equal to 1 and this number is bigger, the previous number is bigger. We always want to change the previous number. Yeah. Now let's just check another case. Maybe, yeah, we still find two numbers that is decreasing. So the problem is that we are not sure which number to change. Yeah, whether we're gonna change this number A or we're gonna change this number B. We don't know it yet. But what if we know something about the previous? So this is my current number, and this is my previous number. But what if we know the number before the previous number, just one place before it? So maybe let's just check. Maybe this number. Yeah, maybe this number is smaller than A. Maybe this is C. It is just before this number A. Yeah, so maybe this number C is smaller than A, but we are sure A is bigger than B, so B gonna be smaller than A, but we find a number. Maybe this, yeah, maybe this C is, we're gonna compare with this number B. Maybe this is C is bigger than B. So what are we gonna do? You know, this number C is gonna be bigger than B. Can we just change this number A? Is that possible? Maybe we want to decrease this number A. Normally we're gonna decrease it to B. Yeah, to this place. But it is even smaller than C. It means it is not possible. So while we are checking the current number, definitely we are sure the previous number is gonna be bigger. But there's one number before the previous number. There's another number. Maybe this number C is bigger or equal. Yeah, maybe this number is bigger than B. So what are we gonna do? If it is bigger than B, so instead of changing this number A to B, we want to change this number B to A. So in this way, so this is gonna be this number B. Yeah. So in this way, as you can see, it is a non-decreasing. It is still increasing, and this is okay. But what if this number C is even smaller than B, or equal than B? So if this number C is smaller than B, so this is gonna be C, and this is B. Now what are we gonna do? Whether we're gonna change A or B? Definitely we want to change B. Yeah, because this number C is smaller than B, and this A is bigger than B. Yeah, so this A is bigger than B, and this C is even smaller than B. Definitely, we want to change this B to A. Or we can also change this A to B. It seems it is okay. Yeah, now I think we can start coding according to this idea. So if this number C is bigger than B, we cannot change we cannot make A smaller, but we need to make B bigger. Yeah. Otherwise, we can change A or B. It doesn't matter. Yeah. Now let's just use this idea to solve the problem. So we're gonna prepare n gonna be the length of the nums, and we're gonna prepare a counter gonna be equal to 0. Now we're gonna check. So for I in range from the second number to n. So we're gonna check if nums I is yeah, my current number, if it is less than the previous number, it's gonna be I minus 1. Yeah, so the code gonna be plus equal to 1. Definitely I find a place which is decreasing, but I don't want to find such place. So the code gonna plus equal to 1. Now I want to check the I. If I equal to 1, yeah, so if I equals to 1, this is for such case. If I equal to 1 and this 4 is bigger than 2, so what are we gonna do? Yeah, we always want to decrease the previous number, so it's gonna be nums I equal to num I. So the nums I minus 1 gonna be equal to nums I. So this is for the first case. So if I equal to 1, we're gonna decrease the previous number. Yeah. And what if yeah, and what if nums I, this is nums I, what if nums I is bigger than nums I minus 2? So this is I minus 2. Yeah. So if nums I is bigger than nums I minus 2, so say is I minus 2. So this means we're gonna change nums I minus 1 to nums I. Yeah. Yeah, we want to decrease this number instead of increase, because if we increase, maybe it will have an influence for the next number. Yeah. So or nums I is more than and equal to nums I minus 2. Yeah, so we're gonna always change the previous number. So this is I minus 2, and this is nums I, and this is I minus 1. Yeah, because this B gonna be more than and equal to C. Definitely we want to decrease A to B. Yeah, to make it work, instead of increase B to A. If we increase B to A, definitely what about the next number? What about the next number is here? It didn't work. Yeah. What about this number is less than A? It didn't work. So according to the greedy idea, we always want to decrease A. Yeah. And for the third example, yeah, let me delete these areas. So for the third example is that this is A and this is B. A is bigger than B, and this is C. C is bigger than B. What if C is bigger than B? Whether we're gonna decrease A or we're gonna increase B. So if we decrease A, it didn't work, as I said before. A gonna be here equal to B, but this is decreasing, it didn't work. Yeah, we must increase B to A. Yeah, this is for the third case, we have to increase it. So else nums I gonna be equal to nums I minus 1. Yeah, so this is the idea. Finally, the count should be less than or equal to 1. That means we're gonna at most have one modification for the numbers, otherwise it's gonna be false. So let me just run it. As you can see, it works. Now let me submit it. Yeah, so for this idea, the time complexity gonna be O(n), because we just used the one for loop, and everything is just greedy, and we just need to compare two numbers, whether it is A or B. We need to change it, and whether we're gonna change it, it depended on the previous number, or it is dependent on how many previous numbers do we have. If there's only one previous number, and definitely we want to decrease the previous number. As you can see, it works. Yeah. If there are many numbers, so we're gonna compare this B and C. So if C is bigger than B, so for the next step, we cannot decrease A anymore. We must increase B. Yeah, maybe for solving such kind of problem, we have to make a drawing. And by making the drawing, we can find the different cases. Otherwise, we're gonna make a lot of mistakes. Thank you for watching. See you next time.